Now we're going to use slope in some application problems. And these problems will involve an average rate of change, and all you're going to be doing is using that slope formula, which was slope, or M as we call it, equals y2 minus y1 over x2 minus x1. So in other words, it's just the same as the change in y over the change in x. Change in y over change in x. And that triangle, delta, means change. So as you read these slope problems, try to identify what two variables are changing and which is going to be my y and which is going to be my x. So in our first problem, we've got in 2000, the United States national debt was $5.63 trillion. In 2008, the debt was $9.99 trillion. What was the average rate of change in the U.S. national debt from 2000 to 2008? So the two things that are changing are the amount of the debt, which went from $5.63 trillion to $9.99 trillion. So variable 1 is amount of debt. The other thing that's changing is the years. We change from 2000 to 2008. So the two things that are changing. Next thing you need to identify is which one is going to be on top of my slope ratio and which one's going to be on the bottom. So what's helpful there is to think about how would you talk about the national debt. Well, you talk about it in dollars per year. You would talk about it in dollars per year. So that should help you understand that the change in the dollar amount is going to go on top and the years are going to go on the bottom. So let's set up our slope ratio. M equals dollar amounts. Now the dollar amounts are increasing. They're going from 5.63 trillion to 9.99 trillion. Now that's going to mean a positive slope. So in order to get a positive slope, I've got to take the larger number and subtract from it the smaller number, 5.63. Alright, so that I get a positive value. And the years are changing from, in year 2008, 9.99. So I want to make sure that the dollar amount is with the year here, one above the other. And I'm subtracting from that the year 2000. Again, this is so I get a positive amount because we have an increase. Alright, then I take my calculator or my brain and I subtract the tops. Let's see, 9 minus 3 is 6, 9 minus 6 is 3, and 9 minus 5 is $4.36 trillion on top. 2008 subtract 2000 is 8 years. And then I pick up my calculator and I calculate that amount. So 4.36 divided by 8, and I get 0.545, 545,000 trillion dollars, which is a little strange to say. Again, this is a dollar amount per year. So I want to write it like this. I want to put units on my answer. Now, this is hard to understand, so you might want to move your decimal point. And if I move it 3 spaces, I'll be in the billions. So this is optional, but this answer might make more sense to your audience if you're talking about the national debt. So I know that billions and trillions are 3 decimal places apart, so if I make this 3 decimal places larger, they'll put me back down into the billions. But if you get at least this answer, I will be happy. If you can think about it and change it to a more reasonable answer, go for it. We'll go on in the next example and look at cigarette smoke per year.